Yes, Sat Sri Akal students. So today we are going to start with class 10. The chapter is surface area and volumes. In this chapter, in this lecture, we are just going to discuss the important formulae we will be using in order to calculate the surface area and volume of combined solids. We'll be combining some solids. So first we have cuboid. Well, cuboid, this is, you can see the length of cuboid, this is a breadth and this is the height of cuboid. Now, when we talk about the total surface area of the cuboid, which has six faces, it has, these are the faces, and these are known as corners or edge. These are known as corners or vertices of the cuboid, and these are known as edges of the cuboid. So we have so many edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And we have six faces and we have eight corners or eight vertices 1, 2, 3, 4, 5, 6, 7, 8 vertices. All right. So total surface area is a surface area of all the six faces, right? So now we have one surface area. Uh, how do we write it? Just write down length, breadth, height. Multiply length into breadth, LB, plus multiply B into H, that is BH, plus multiply L into H. So LH. This whole multiplied by 2. Why? Because look at this face, front face. Similar congruent faces here on the back also. So every face has one congruent face like that only. So three faces are congruent with other three faces. That's why total surface area of a cuboid is 2 into LB plus BH plus LH. All right. Now comes the total volume of a cuboid. Volume is a space which is 3D, three-dimensional. It occupies. So that will be simply length into breadth into height unit cube. And in total surface area will have unit square because it is two-dimensional thing. Total surface area. It is achieved by multiplying length and breadth or breadth and height or length and height. Okay. Now comes the diagonal of the cuboid. Now, let's understand there are two types of diagonal. One is diagonal of the cuboid, like it's shown with blue arrows. There are four diagonals like this. Look at the front face, take any corner of front face, take its congruent face on the back side, and join the opposite vertex. You'll get the diagonal. This is also the maximum length which can be placed inside a cuboid, maximum length or a maximum pole which can be adjusted inside a cuboid. Well, this would be equal to, let's say, its length, L is length square plus B square plus H square whole under root. This is a diagonal. Obviously, it's a length, so its unit, its unit would be any unit raised to power 1. So this is all about cuboid. We have other diagonal of cuboid also, like front face also can have diagonal, two diagonals like back face, side face, top faces also. Then we also talk about lateral surface area of cuboid. Lateral surface area of a cuboid. Well, there's a formula to calculate that. Lateral surface area. How do you calculate? Simply calculate the perimeter of the base. Perimeter of base. See which base the cuboid is standing on. Simply multiply that by h. So very interesting. If a cuboid is the little surface area would depend upon on which face a cuboid is resting. Like in this case, the cuboid is resting on L into B. It may rest on H into B also. Then L will be the height, right? Uh, so it's like that, it depends upon lateral surface area would depend upon in which on which face the cuboid is resting. We will not take the area of that face on which it's resting and the opposite top area. We will not be taking both the areas. So we will get lateral, means on the sideways area. So we'll get area of this one on the back side, on the front side, and this side on the back on the side. These four areas will be getting, and that's perimeter of the base. Very easy into height. All right. Perimeter of the base is meter unit into height is unit. So again, you get unit square as little surface area. Having done with this, and then we have cube. All right. In case of cube, simply the only difference is length is equal to breadth is equal to height. Let's say that is equal to A. Right. So first, total surface area of the cube, I simply put LBH as A. So the surface area of every face is A square. When this is A, its breadth is A, its height is also A. All right. So total surface area of one face is A square. There are six faces. So 6A square is total surface area. You can put A also here. So it will be A square plus A square plus A square, 3A square into 2, 6A square. Fine. So then comes the volume of the cube. Well, the volume of the cube is again length into breadth into height. So it will be A into A into A. So that will be A cube. So we can write it as side cube. Side cube. Now the comes the diagonal. Again, two types of diagonal. One diagonal of the face, one diagonal of the cuboid. So diagonal of a cube, that is the maximum length you can place inside a cube, would be, again, it will be A square plus A square plus A square. So it will be, see, A square plus A square plus A square root. So that would be equal to under root 3A unit, under root 3A unit, obviously. So this is all about total surface area. Little surface area, uh, same, formula. Perimeter of the base. Perimeter of the base in case of cube, see, lateral surface area. The perimeter of the base always would be 4A multiplied by height is also A. So little surface area of the cuboid would always be 4A square. Having done with that, now let's talk about right circular cylinder. Right circular cylinder has two, circles, one on the top, one on the bottom. So then first we'll call it, this is solid cylinder. Solid cylinder obviously has this surface generated also and this surface generated also. So first we'll find out the curved surface area. Curved surface area, or we can also say lateral surface area of the right circular cylinder. So it will be curved surface area is, little surface area. Like I told you, the same formula you can apply. Perimeter of the base. Perimeter of the base is 2 pi r into height. So this is the height of the right circular cylinder, right? And this is the radius of the base. Same radius is there on the top also. So 2 pi r is the perimeter of the base into height h. So little surface area would be 2 pi r h. Whereas total surface area, when we calculate, in total surface area, we'll have areas of the top surface also and bottom surface also. Remember, in case of hollow cylinder, these two surfaces are not generated, so we will not take this. So we'll have 2 pi rh little surface area plus the areas of two circles on the top and bottom. So 2 pi r square. So this would be equal to 2 pi r into h plus r. The total surface area of a solid right circular cylinder. Now we want to talk about its volume. So for volume, uh, now area of base into height is a simple formula for volume. You can apply this on any regular solid. So area of base is pi r square into height is h. So pi r square h is a volume of the uh, right circular cylinder. Now we go for right circular cylinder, which is hollow. So Ri is the inner radius and Ro is the outer radius. Now we want to calculate the total surface area. First we calculate little surface area. So we will have two surfaces. One is this curved surface and one is other curved surface from the inside. So obviously lateral surface area, right, or we can say curved surface area, you know, uh, we would write it curved surface area, curved surface area. Well, this would be equal to again area perimeter of the base, that is 2 pi r, one is ro into h, plus this is inside curved surface area also. So 2 pi r I h, right? So this will be equal to 2 pi h into ro plus ri, right? So now it depends upon in lateral surface area. Suppose they say you want to paint it from outside, then you take only outside area, that is 2 pi roh. If you want to paint it from inside, then you take this one also. Depends upon what is the numerical you use this. If they say curved surface, total curved surface area, then it will be this. Okay, but if you talk about total surface area, so in total surface area, this will be there 2 pi h into ro plus ri. At the same time, you see this surface area is also generated. This is hollow. This surface is not generated. So this is also generated. Similarly, this surface is also generated. So this area would be outer circle minus inner circle, right? So it will be pi into ro square minus ri square. So this is total surface area of a hollow cylinder with thickness t. Remember, students always make a mistake in this. And what is the mistake, students? Uh, the when you want to take when you want to subtract the inner diameter from the outer diameter, right, then this will be equal to 2t. But when you want to subtract inner radius from the outer radius, this will be equal to t only. It's very simple. See, this is outer radius ro, this is inner radius ri. So ro minus ri will be t, whereas do minus di will be equal to 2t, because this thickness is coming twice. Fine, this is great. Now we'll have volume or the capacity of right circular cylinder which is hollow. So whatever fluid or whatever solid, whatever things we can put inside this, a space inside this. So its volume will be in a volume. So that will be again the formula for volume is area of the base. So area of the base will be inner. So it will be pi r I square, right? Pi I square into height. This will be the capacity of the this cylinder. Now, suppose somebody wants to ask you that calculate, let's say this is made up of steel. How much is the volume of the steel? So then you calculate volume of outer cylinder minus volume of inner cylinder. In this way, you can calculate the volume of the steel used or what volume of material used to make this. Great. And then we have sphere. Now, in case of sphere, first we will find out surface area of the sphere. Surface area. Surface area of sphere, remember, is equivalent to 4 times the area of a congruent circle. So this is radius r. So it will be 4 pi r square. Remember that. All this can be proven also. We have another video to prove this also. Rope experiment. Surface area of the sphere is 4 pi r square. Then we have volume of the sphere, that is equal to 4 by 3 pi r cube, right? Unit cube. This is r. Very very simple. And then we have volume of hollow sphere. Volume of hollow sphere. Volume of hollow sphere is equal to 4 by 3 pi r cube minus r cube. Well, this is in case that there's a thickness of the sphere and this is the outer radius. There may be a sphere inside in a radius. So this is the volume of the hollow sphere. 4 by 3 pi r cube minus small r cube. Chota r is inner radius and this bada r is outer radius. All right. Okay, then comes hemisphere. Okay, in this case of hemisphere, students, you see this is also r, this is also r. It's half the sphere. But then if it is solid, this surface extra is generated. So when we want to talk about total surface area of a hemisphere, right? So this will be obviously half of surface area of the sphere. So half 4 pi r square divided by 2. You know, this is a half of the surface area of the sphere. But then this surface is also generated, marked with the lines. That is equal to pi r square. So ultimate pi r square. So ultimately, total surface area of hemisphere is equal to 3 pi r square. 3 pi r square. Am I right? Then volume of hemisphere, its volume would be equal to obviously half the volume of sphere, 2 by 3 if it is solid, 2 by 3 pi r cube, right? Having done this, the last is right circular cone. Why it's called right circular cone? Because this is the axis of the cone. This is also known as height. Well, this is also kind of height, but it's known as slant height. We call it slant height, represented by L. Okay, obviously this is the R. So there's a relation by Pythagoras theorem. L would be equal to h square plus r square under root. If the height of the cone, if they simply say height of the cone, this is h, unless they mention it is slant height. So you can find out L from this, or if L is given, R is given, you can find h from this formula. Well, this is done. Now we cannot apply the formula that square when we want to calculate the volume of the cone. We cannot apply this formula that area of the base into height h, because it's not regular. It's not regular. You know, the diameter of the cylinder, diameter of the base circle is constantly getting decreased as it goes up. Becomes the diameter becomes zero on the vertex of the cone. This is vertex of the right circular cone, right? Then comes the volume. Volume of the right circular cone. Yes, we have defined L. Volume would be, now it's volume of the right circular cone. In case students we have a cylinder, a similar cylinder. Let's say this is a kind of cylinder we have, similar cylinder. So that cylinder would also have height h. What will be whatever will be the volume of that cylinder? You know, hollow cylinder. This cone volume will be 1/3 of that. So first we write down the volume of the cylinder. That is, like base circle pi r square h is the volume of the cylinder divided by 3. This is the volume of the cone. Remember that. So you need not remember the volume of the cone. Always remember volume of the cylinder. Pi r square h divided by 3 is the volume of the cone. Remember that. Now comes curved surface area. CSA of the cone. Curved surface area of the cone is equal to pi r L, where L is a slant height. Unit square. Curved surface area. This curved surface area. This curved surface area, right? And then becomes total surface area. So student, total surface area would be curved surface area plus the area of the circle. There's a circle on the bottom also, right? So it will be pi r L plus what's the area of the circle? That's pi r square, right? So total surface area of cone is equal to, just take pi r common, so it will be L plus R unit square. This is the total surface area of the cone. Before you start attempting the questions on combination of solids, like suppose they might say that we have a cylinder like this. On this cylinder, inverted cone is there, solid cone is there. Find the total surface area, volume, or whatever it is, lateral surface area, whatever it is. So you need to be completely conversant with the these all formulae. See the video again and again. This should be on your tips. Once they are on the tips, you can easily attempt all the questions in solid combination of solids. Don't forget to subscribe our channel Learn CBSE. You know, my name Engineer Omkar Singh. This is the name of our YouTube channel Learn CBSE Engineer Omkar Singh. Possible, subscribe it, share with your friends. Thank you very much.